Mass number. Mass number is the number of protons plus neutrons every single time. Okay, in a ground state atom, the number of protons equals the number of electrons, which also equals the atomic number. So when I give you that problem with the table, you know all three of these are the same. Protons, electrons, atomic number, all the same. Once you have those, you can find the element, because you look on your periodic table, go to that number and find it. The only other thing that's weird is the mass number. So for carbon, whose atomic number, or number of protons, is 12, if I tell you that I want carbon 14, which is used for dating things, even though it's not always accurate, carbon 14 has a mass number of 14. So how many neutrons does it have? 2, because the number of protons is 12, so it must have 2 neutrons. Not to be confused with Jimmy.
Wait.
That is a television program from my childhood. Or from my teenagerhood. I don't know, but I'm sure Favi will look it up later. Yes?
What is P?
Proton.
Oh, sorry.
E is electron. Okay, so that's that. Expect to see that table on your test. Okay? So, study the table. Make sure you can fill in all the spots. Got it. Okay? Don't do anything crazy. Like I've seen a lot of weird things going on with that table. Protons, electrons, atomic number, all the same. Okay, let's talk about naming. There are 1, 2, 3, 4. I felt like I've had to sneeze for like an hour now. And I keep saying watermelon, and then it goes away, and then I'm frustrated because. Okay, so easiest thing to name: covalent compounds. What must we know for covalent compounds? The prefixes. Right. What are the prefixes? 1 is mono. 2 is di. 3 is, right, hydrogen dioxide. Di. Tri. 4 is
Quad. No. Or tetra. Yep.
tetra. 5 is
Hexa. Octa.
Penta.
Yeah.
Like
Pentagon.
like pentagon, like the place with 5 sides.
I don't know my sides.
6,
Hexa.
7.
Hepta.
Septa.
It's septa.
Yeah. Ha.
That's me.
And that's the T.
Sound a little personal.
8,
Octa.
Octagon.
9, not related to you.
Nana.
10,
Delta.
and so on. So, how do you name covalent compounds? You are going to take the name of the first element, the name of the second element, chop off the end of the second one, replace it with IDE, and then apply the appropriate prefixes in front of each of them. Remember that you will not do mono here. Okay? So, what is like PF3? Go.
Phosphorus
No, like write it down. Write it down, buddy. Give everyone needs an opportunity.
Thank you, Micah.
Okay, P is F is okay. So
Fluoride.
phosphorus chloride, but now I must add the prefixes. I have 1 of these, so I'm not going to put mono there. I have 3 of these, so phosphorus trifluoride. Did you just do the snappy thing?
No.
Where you like snap to show that you approve of whatever someone did.
Hey.
Isn't that what they do in like poetry concerts?
Yeah.
Poetry concerts?
Concerts, yes, the poetry
Golf.
concert.
It's the golf. The golf.
Yeah, they're like, my cat died.
Have our own golf. I'll be like.
Nice shot.
Why would I go? No, go to the golf.
Okay, how about this one?
Because I'm a rich white man.
We're not rich or what? Or rich.
Okay, go. Dylan, bye. Come back when you're ready.
Oh, I can't come back?
When you're ready.
Oh.
I'll let you assess that. However, next time. Less so. Okay, N is nitrogen. O is oxygen. Okay? There's 2 of these. 3 of these. Happy campers? Okay, again, use that website. It will check your answers. This is helpful to you. When do we have covalent compounds? How do we know it's covalent? A lot of you guys were adding these to random things that weren't covalent. How do you know if something is a covalent compound? Please.
If they're like the same of a category, no, of like.
Yes, a specific category though. Yeah.
If they have the numbers. Same
No.
family?
Nope.
No.
Ish.
Non-metal and a non-metal?
Non-metal and then non-metal. That is the only time it will be covalent. So, the little corner of your periodic table where you have nonmetals, that's it. So, we're really talking about like 10 elements total that can be combined to make a covalent compound. That is carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, selenium, bromine, iodine, whatever AT is, astenine,
No, the halogens, I mean.
and
the-
hydrogen, and halogens.
No,
Yeah.
sorry, the noble gases are not.
No.
Oh, 'cause
They really don't bond with
Yeah,
anything.
'cause- okay.
So we would just, xenon's the only one that bonds with itself, so it's just xenon. So, this is it, right here. These are the ones. We add hydrogen because it's weird and does pretty much everything. Okay. So, that's it. If you see these, that's what you're working with. Only non-metal to non-metal. When we have a metal and non-metal, what kind of bonding do we have? Ionic bonding. Okay, metal and non-metal is ionic. What are the rules for ionic bonding? You have the 2 names. Let's pick the easiest one that we see every time, which is not cool.
Salt.
Na is,
Sodium chloride.
Cl is chlorine. Chop off the ending, add IDE. What's the only trick? Sometimes, if this is a transition metal or a post-transition, then we have to indicate the charge of the anion here. Okay? What is the anion? It is the positive one. Which one is always the positive one? It is the metal or non-metal?
Then.
Which ones have positive charges? Metals or non-metals?
Metals.
Metals. Metals are defined by the fact that they have a positive charge. They want to lose electrons, which is why we use them in wiring, because they like to transmit electrons. They don't just hold on to them. They're like, ooh, mine, and then keep it. That would be a horrible wire. Imagine plastic wire.
Wait, there's what in wires?
Ooh, that
Metal.
would be terrible.
Oh. That's why
Plastic
you don't-
wires would not work. Why? Because the plastic non-metals like to keep their electrons. They don't want to share them. They don't want to transmit them. They don't want to get rid of them. They keep them. It's not helpful. It is not helpful for the electricity. It is not helpful for the light that is still on in your room as you're studying chemistry, because that's your simp.
Stop.
And
Just stop using it.
okay.
That's simply.
It's okay. You use the term, so now I'm going to keep using it.
Whatever.
He's gonna
He's gonna use dirty towel. What happened to, what happened
be a
to
simp for
Abe got
Satan.
no time?
Anybody got time for that? That's right. Are you allowing Satan to be your simp?
Are you simping for sin?
Wow. Simp is not a person, it's a verb.
Oh, is Satan simping
Who is?
you? Or are you simping Jesus? There's an M in there. It's not sip, it's simp with an M.
Have mercy.
Alright, so if it's a transition metal, it can take more than one charge. You have to specify the charge. That's it. Okay, so let's try some. Okay, so what's our anion? Anion, positive charge. Which one? Copper. What's our
Oxygen.
cation? Hydroxide, because this has a negative charge. It's ionic because in order to figure it out, you have to break apart the ions. You have to look at the ions. So copper, we don't know what charge it takes because it's a transition metal. Hydroxide, from your memorization of life as you know it, takes what charge? Negative 1. So in this case, what charge is copper taking? Positive charge. Because in order to balance out, I have one copper and one hydroxide. The copper must equally balance the hydroxide. So it is copper plus hydroxide minus. So what is my name now? Well, Cu is copper. OH minus is hydroxide from your polyatomic ion. Since copper is a transition metal, I must include the charge, which is plus 1. So break it apart into its ions, find the charges on each of them, and then indicate your name.
Sodium's a metal.
Yep.
You can make.
Why is sodium a metal? Because it wants to lose electrons. You thought it was that thing? Yeah. I know.
It's also not alkaline.
But it's an alkali metal, so they're like very shocking and like not, if you remember when we were going over the properties of them, they're not like metally, like the metals you think of are transition metals. Because they're like in wire and they're able to be like, they're very ductile, so you can pull them into like long wires, or if you smash them, they spread out. Not true with the alkali or alkaline earth because they're brittle, so they'll break apart. Which is why you don't have sodium wires. So that would be bad. Okay, what about this one? That's the same one. Here we go. Okay, Cr is
Chromium.
chromium. And is it a transition metal?
Yes.
Yes.
Yes. So we have to figure out the charge. Okay. So chromium oxide, that's easy. What charge is the question? The answer is everybody.
2.
Wait, no.
2.
2.
Why? Break it apart into the ions. Oxygen has a -2 charge always because it's a non-metal. And oxygen always takes a -2. Chromium would then have to be a +2 to balance it out.
So, what if we like don't know? Is there a way you can do it?
Then you lose.
Okay.
You have to know.
So like taxes.
Pretty much. Yeah.
You go.
Like if you don't know the loopholes, then you just lose money.
Do you know loopholes?
No, but like if you donate to a charitable organization, you can deduct that on your taxes, like tithing.
Yeah,
But
I'm trying to tithing.
if you don't, then it's like, well, sorry. Like the government's not gonna be like, didn't you give all that money to the church? Here, have some money back. They don't care. Nobody got time for that.
Churches do the like annual.
Anybody got time for that?
Give you your tax, that's why you
That's
have
why they give it.
That's why you have a job,
And
first of
when you,
all,
like,
and then you,
always
yeah.
ship with your name.
Moving on. All right, so
I did so much.
harder way to go is from the name to the formula. Okay? So, what do we do with lead for sulfate? Okay? Same middle step, and then we generate the formula. So, what is lead? What's the symbol?
PB.
What's the charge on lead?
4.
Plus 3.
Plus 4, because that's a 4. Sulfate, we already know. What's sulfate? Check your notes.
Negative.
Check something. Check your periodic table.
+1.
Negative.
I know, but it's SO something. So check your notes. Check your polyatomic ion list.
Isn't there a 3 somewhere? Isn't there like 3
Minus
Open, what's your?
SO what?
SO -2.
Mine's like a
3?
minute though.
Is it 3?
Hers
Because I have it right here. Just want to make sure. -2. 2 minus.
Or 2 minus. It doesn't matter.
Same thing.
Okay, that's sulfate.
How do you know that there's, no,
Because.
How do you know what?
3? How do you know that it's 3?
You memorized it.
8, 3,
Or,
I, 2.
more correctly, Ryan and Grace memorized it. And or they looked at their notes and found it.
So, Mr. Bonnet, 8 is 3.
No. It's all different. You have to memorize them. You have to for our viewers at home, you have to memorize them. For our viewers here, you have to memorize them. There's no way to know. There's no pattern. 8 is kind of like 3 or 4 most of the time. 8 is usually 1 or 2 most of the time. Is it always the case? No. Phosphate's like PO4 minus, and perchlorate does follow that rule. It's weird. They're all different. So you have to memorize them. You must. Otherwise, you're going to sit there on the test and go, and then waste a bunch of time. Memorize them. It's like friendly angles. Just know them. Sine 30, 1/2. Done. Yes. Yes, so you can sip the water.
Yeah. Not sip.
Okay. So now, what's the equation? What's the formula? Is it PbSO4 or SO3? No. Why? Because 4 minus 2 does not equal 0. So I need 2 of these per 1 of those. So that's your formula.
Oh, wow.
The challenging. Okay. Speaking of phosphate, iron 2 phosphate. Iron is Fe plus 2 phosphate. Check your polyatomic ion sheet.
E -4. So you said.
Check your polyatomic ion sheet. Or note cards or something.
Wait, why is it a P1?
Because it's phosphate. 8s and ites have an O in them. Okay, phosphate. Come on, guys.
PO -4?
Wrong. But close. Good start. What do you got?
Is it PO4 minus?
Come on.
Well, she checked the sheet. You just sat there and guessed. She checked the sheet, and then it's done.
I didn't check this.
You didn't check? You didn't check? You just guessed.
It's PO4 3 minus 3.
Sounds about right.
It is right.
Like it is right. So, how do I get this to balance? How many of these do I need?
3.
How many of these do I need?
2.
2. Why? Because 3 times 2 minus 2 times 3 is 0. So I'll need 3 of these. To balance out 2 of those. The trick is you can always just move these across and then reduce. So like here you could have done 4 and 2 and then you reduce that number. Here you could have done, oh wait, go that way. Anyways, So, how will you learn these? How will you know these? You must
Remember,
practice and memorize. That's the simp.
yes.
Or is that the T? That's the T.
Please.
No, I don't know.
Put on the-
That's
that
the
way they can
T. Okay? You must memorize, you must practice. Okay? You're not just going to out of the blue be like, oh, I get them all perfectly right. No. You must the practice. Which is why I'm forcing you to make Kahoots. Hopefully it will help. Perhaps it won't. We'll find out.
You know where the game is phrase out of the blue?
Okay, next.
You can change the music on.
We have,
I put the red game.
ladies and gentlemen, let's stay on task, shall we? Okay. Next, naming polyatomic ions. How do you name polyatomic ions? You memorize them. That's right. Just like your friendly angles. And once you know them, you'll have them memorized for the test and then forget them and then teach chemistry and have to re-memorize them later. Okay, what are the general rules?
Pyramid scheme.
If it ends with a hypo thing ite, that's the lowest number of oxygens. Then it's your thing ite, then 8, and then per 8 is the most. So low oxygen, highest oxygen. So for chlorine, chlorine has all of them. So it is ClO minus, ClO2 minus, ClO3 minus, ClO4 minus. Nice thing is that all of the ones for any given element have the same charge. So all the chlorines are minus. All the sulfates and sulfites are, I think, minus 2. Yeah. All the phosphates, phosphites, minus 3. If you look at the periodic table, phosphorus likes to take a minus 3 charge. Sulfur likes to take a minus 2 charge. Chlorine likes to take a minus 1 charge. That may help you as you study. Okay? Right? So like chlorine, minus charge. So this likely to be a minus. It might help. Does it work all the time? Absolutely not. Like hydroxide, which takes a minus 1 charge. But that is a trend. So, less oxygens, you got an ite. More oxygens, you have an 8. That's about it. Thank you. Is that the T? Apparently, someone has some screws loose.
This chair's like popped out.
Huh?
This chair's like popped out. Just be like, just-
Wow. Taking apart the chair?
Oh.
Thanks for doing that. I appreciate you making more work for me. Perhaps I should make more work for you as well.
Well, it's not.
Interesting. Okay, so that is polyatomic ions. Next, we have naming acids. So, 2 types of acids that we name. One type includes the polyatomic ions. The other type has a single element attached. So, the ones that have a single element attached are binary. So, you usually have hydrogen and 1 element. For example, HI has appeared on many of your quizzes. But even easier than that, HCl. What is HCl? Hydrochloric acid. Okay, so how do you form this one? I like to think of HCl and then remember how to do it for the rest of them. You put hydro in front, the element name with an ic at the end, and then acid. So HBr would be hydro bromic.
Oh.
Boring would be B. Okay, HI is hydroiodic acid. How about H2S? Don't be bothered by the H2, that's just how many hydrogens are required to balance it out. So hydro sulfuric acid.
It's like when you cut off the endings for the IC.
It's all
just
different.
all different.
It's whatever sounds good. You okay? You want to get out of here?
No, I was just
You're like,
wondering when we're gonna start working on our good because you said we're gonna.
chemistry is not a simp. Not your simp.
How long are we getting out of this round?
Not your sin.
Okay, the other one is when you have an acid that includes a polyatomic ion. Okay, so let's take our favorite chlorate. Okay. If we make an acid with that, we will see an H in front. Oh my gosh, I lost it. There we go. No hydro. This is just chloric acid. If we take chlorite, that would be chlorous acid. So, how do we form these? If it was an 8 before, chop off the ending, add IC. If it's an ite, chop off the ending, add OUS acid. So you could also have a perchloric acid and a hydrochlorous acid. So take your favorite polyatomic ion that ends in ate or ite. Simply take off the ate or ite and add ic acid or is acid, depending on if it's ite or ate. Ish. Okay, so that is all of naming. Woot.